What is switching in general words? I hope everyone has already completed CCNA. In CCNA also we talk about this switching thing. So what do you understand or what do you mean by switching? Switching is a switching to take your data from one place and to put it on some other place. That's switching. Like for an example, if you talk about a router receives a packet on one interface and then switches it out from a different interface, sometimes through a same interface as well. That depends, but it does switching. Similarly, your switches will do the switching. Now, switching can be done at different levels, like layer 2 switching. So when I say layer 2 switching, which means your data will be switched based on layer 2 addresses. That's layer 2 switching. So when it comes to layer 2 switching, we have got multiple technologies. And Ethernet switching is one of them. And this is what we are going to cover during our training. We are going to cover only Ethernet switching. But apart from Ethernet switching, we also have got frame relay switching. I'm not sure that if you have ever heard about the frame relay switching, but it was an older technology that we used to have in past, especially for WAN, wide area networking. Nowadays, we are running everything over Ethernet. When your wide area network WAN connections are also based on Ethernet technology. Like Ethernet connections are coming to your home, even for broadband connections. If you are buying a internet lease line, you are getting a Ethernet connection. If you're buying MPLS connection, you're getting an Ethernet connection. But earlier it was not like that. Earlier we were using frame relay a lot, which was a layer 2 technology. And it was used in WAN, wide area network, not inside local area network. And then we also had another technology that was ATM technology, ATM switching. Again, layer 2, but only for WAN, wide area networking. We don't use them anymore. So basically, as part of this course, we are going to focus only on Ethernet switching, which means that we will have to learn about the Ethernet switches. And that is where Cisco Catalyst switches fits in. So Cisco Catalyst switches fits into Ethernet switching. They do Ethernet switching. Those are the Ethernet switches. You can call them Ethernet switches because they are using the Ethernet technology. And that is why all those type of switches will have those Ethernet interfaces, maybe fast Ethernet interfaces, maybe gigabit Ethernet interfaces, maybe 10 gigabit Ethernet interfaces, maybe 40 gigabit Ethernet interfaces, maybe 100 gigabit Ethernet interfaces, and that's the max capacity at this moment. So the switches are having maximum up to 100 gigabit Ethernet interfaces, not more than that. I mean, I haven't seen at least if there are any higher bandwidth interfaces are available on Ethernet switches, but I haven't seen that. Anyways, coming back to switching fundamentals. So I hope that you understood that switching is a mechanism where you simply switch your data from one interface to another interface. That's switching. Now, when we talk about switching, as I told you, like we can call it layer 2 switching. We can also talk about the layer 3 switching. So in layer 2 switching, basically you switch your data based on layer 2 addresses, and under layer 2 switching, we also have got this Ethernet switching. In Ethernet switching, we are switching data based on MAC addresses because MAC address is a concept of the Ethernet switching. MAC address is part of the Ethernet technology. So if you are using Ethernet technology, that is where we are using MAC addresses. Now, all of you must be aware with the MAC addresses. If you are not really good with the MAC addresses, then it is going to be a problem for you. Doing troubleshooting, making configuration, validating configuration, in all cases, you would face trouble. So you have to be really good with the MAC addresses. Like what is MAC address? How do we allocate them? How do we learn them? And how switches are performing the switching based on MAC addresses. So that is very critical for us to understand all those smaller concepts. Those are very smaller concepts basically, but it is very important for us to understand all of them. So forwarding of the frame based on layer 2 address is known as layer 2 switching. And devices that forwards the frame based on layer 2 addresses are known as layer 2 devices, such as layer 2 Ethernet switches, or maybe layer 2 frame relay switches, or maybe layer 2 ATM switches. So basically here in this course, we are going to cover only Ethernet switching. And so layer 2 switch forwards the frame based on layer 2 address only. Layer 3 switches will switch your data based on layer 2 as well as layer 3. That is called layer 3 switch, or that is called layer 3 switching basically. So a device which has got a capability of doing layer 3 switching can also switch your data based on layer 2 address, can also perform layer 2 switching. And then we talk about multi-layer switch. So multi-layer switch can switch your data not only based on layer 2, not only based on layer 3, but also based on Layer 4. And at layer 4, we get the port numbers. At layer 4, we get what? Port numbers. In nutshell, or I'll try to make it a little easier for you. So basically, multi-layer switches can also perform netting, network address translation, because when you do the netting, you create a net table. A net table gets created based on the port numbers. And that's where the port numbers are being used to switch your data. So basically, if you talk about multi-layer switch is going to be that switch that supports netting, network address translation. If your switch is just doing the routing and cannot perform netting, then you call it layer 3 switch. But if your switch is also supporting netting, network address translation, then you call it multi-layer switch.
But then if a switch is performing routing, then ultimately
it's not necessary that it will also support netting. Usually all your routers will support netting, but it is not true in case of Ethernet switches, catalyst switches.
So basically
it depends platform to platform. Some switches will support netting, and most of switches will not support netting. They do support routing, but they don't support netting. Okay, modern day campus area network is all about Catalyst 9K series of switches. As you all should be aware that nowadays we are using 9K series of switches. That's a Catalyst series of switches within Cisco. Remember that these Ethernet switches are not only offered by Cisco. Cisco is not the only OEM, is not the only company that is manufacturing Ethernet switches. There are many other companies, even I mentioned them yesterday. I clearly told each one of you, even yesterday I was talking about Juniper, Dell, HP, Aruba, all those vendors, apart from Cisco. But Cisco is most famous, most of the market is captured by Cisco. So mostly customers are using Cisco devices. So that is why we all are sitting here and learning the Cisco technology. If customers were using Dell, then we would have learned Dell switching, Dell technology. So it all depends on demand. What is in demand, right? So since Cisco is in demand as compared to other OEMs, so obviously we are learning the Cisco technology. And there's one more thing: if you learn Cisco technology or any one of the technology, like if you are having expertise over Juniper routers and switches, then it is easier for you to work on Cisco routers and switches. If you have got expertise over Cisco routers and switches, then it also becomes easier for you to work on Juniper routers and switches. Why? Because the technology remains same. Only command syntax gets changes. There are few things which are vendor specific that will be obviously different vendor to vendor, but mostly if you are talking about the open source technologies like Ethernet frames, VLAN, Ethernet switching, MAC address table, spanning tree protocol, all of these are open source technologies, right? Open standard technology. So all those technologies are common across all the OEMs. The only difference would be to configure those. Let's say if you want to create a VLAN. So the command to create a VLAN would be different when you compare Cisco with Juniper. So only command syntax will be different. But if you understand the concept, like what is VLAN, why do we use it, how do we create them, and then how do we allocate interfaces into a VLAN, then the only difference would be the command syntax between the Cisco and Juniper. The rest will remain same. The concept will remain same. The definition of VLAN would remain same. The work of VLAN, the workings of the VLAN would remain same. Anyways, when it comes to Cisco, then nowadays we are using 9K series, 9000 series of switches, and we will see them. One of the major advantages of these switches is the ability to be managed by a controller, which is called DNA center. Now, Cisco has renamed it. They have renamed this DNA center as Catalyst, what they call it.
Cisco Catalyst Center.
Catalyst Center.
Catalyst Center. So they have renamed this DNA center as a Catalyst Center. The new terminology is the Catalyst Center now, which gives us software-defined capability, which means that you would be using a software to configure your switches, which means that you would have access to a centralized controller. And from there, you are going to monitor, you are going to manage all your switches. And not only just your switches, but also wireless LAN controllers, your APs, all these devices which are used in local area network, whether it is wired or wireless. Because when it comes to local area network, you get both technologies, like wired technology as well as wireless technology. So for wired technology, switches, Ethernet switches are essential, right? Whereas for wireless, not only you require Ethernet switches, but also you would require access points for building up wireless infrastructure. But then, to manage your access point, like what if you have got 100 access points at your location? Are you going to manage them independently? Are you going to manage them individually? You can manage them, obviously. I mean,
Wireless
technically,
controller.
it is possible to manage all the access points individually, which is possible. But the point is, we don't do that. We don't do it. I was talking about the access points. So we could manage them individually, one by one. What if you have got 100 access points? Like you have a big floor, and you would see that for the big organization, it is not a big deal to have a big floors, larger floors, and having multiple floors in a same building. So you have to install the access points accordingly. And if you have got hundreds of access points installed in your infrastructure, then it is very difficult to manage all of them individually. And that is why we use a centralized controller to manage all our access points, which is called wireless LAN controller, WLC. So Cisco is also a manufacturer of WLCs. So we can also use Cisco WLC. But at the end of the day, Cisco WLCs will also be connected to your switches. Your access points will also be connected to Catalyst switches. That's what makes it local area network. That's how you construct a local area network. So it could be wired LAN, it could be wireless LAN. And you can manage your local area network using this centralized controller, also known as Catalyst Center. So from Catalyst Center, you can also manage your wireless LAN controller. You can also manage your APs. You can also manage your switches. And that is called software defined networking, SDN, because you have got a centralized controller from where you can do now everything, not only monitoring, not only troubleshooting, but also configuration. Earlier, all those things were not there. And that is why being a network engineer in past, the job has been really tough. But nowadays, doing this job is becoming really easy because of having all these centralized controllers. And you know what? It is not necessary for us to use the physical controllers. Cisco is also, and some other vendors are also providing solutions where your controllers are hosted in cloud. Like within Cisco, we have got a Meraki. I'm not sure if you have heard about the Meraki, right? So Meraki solution is also out there, provided by Cisco. So Cisco acquired Meraki a couple of years back, not couple, it has been many years now, but Cisco acquired Meraki, and now Meraki is part of Cisco. But Cisco is selling that Meraki solution separately. They don't call it Cisco devices. They still call it Meraki devices. So like Meraki is a complete ecosystem or a complete solution that they provide to their customer. Like they have got Meraki MX firewall / router that works as a router as well as firewall. Then they have got switches, they have got access points, and then they have got a controller hosted in cloud. They don't provide kind of on-prem or a physical controller kind of thing. No, they don't. So you control everything from that cloud hosted controller. And it is super easy. You just have to provide internet connectivity to all of their devices like MX firewall, to their switches, to their access point. The moment all those components having internet access, then after you see them on the cloud portal and then make the configuration changes from there. So that's Meraki. My point is that we are not going to learn anything about Meraki here because Meraki is not included in your content. We'll talk about it a little bit, but not really in depth, or we are not going to learn that how we work on Meraki devices. But yes, that is also one of the emerging technology, I would say, because almost all the smaller customers, like all those customers who are having budget constraint, are moving on to Meraki or maybe some other vendor. They're not going with Cisco traditional wireless infrastructure because that is much costlier for them. Meraki has reduced the cost for their customers a lot as compared to the Cisco solution. And that is why Cisco acquired this Meraki solution. Because now Cisco is like a shopping mall where you can go and buy anything. Whether it's a cheaper solution or an expensive solution. Anyways, most of the switches that we use nowadays are routing capable, which means that switches are supporting routing feature, which means they can perform layer 2 and layer 3 switching both. Earlier, it was depending upon like your architecture. Generally, access layer switches were layer 2 switches in traditional networking. But nowadays, there is nothing like access core. It's all about layer 3. So everywhere we are using the layer 3 switches. But yeah, I mean, if you are working on an older infrastructure, then you might find those layer 2 switches as well. But nowadays, if you are, refreshing the switches, rebuilding the infrastructure, or maybe, there is a greenfield environment. So there are two terminologies that I'm going to use in future: brownfield and groundfield network. So brownfield network is that network which is already established, and now you are just making changes into the existing environment. That is called brownfield environment. Greenfield is like which you are you are just building it up. That is called greenfield environment, that you are building up from ground zero. Like you are building up a new infrastructure that we call greenfield environment. Brownfield is like which is already in place. You are just making some changes into that. You're refreshing devices there or whatever you are doing. But brownfield is your existing environment, existing infrastructure. So if I say brownfield environment, so think in that way. If I say greenfield environment, then think in different way. Anyways, let's go ahead and see what sort of switches we have got. So when it comes to Cisco, right? So in Cisco, we have got this Catalyst family of switches. Now remember, this is not the only family of switch. They also have got Nexus switches. We should be aware with it, right? And also they have got the Meraki switches. But in this training, we are going to focus only on the Catalyst series of switches. So when it comes to Catalyst series of switches, then we have got 9K series of switches. At top, we have got this 9K. This is the latest one. And this is the most famous one at this point of time. Then earlier, we used to have 3K series of switches, Catalyst 3K, where we used to have 3650, 3850, 3700 series, 3500 series. And we used to have 4K series of switches, 4500, 4503, 4504, 4505, not 4. 4507, 4510, and we had 6K series, 6500. Within 6500, we used to have 6503, 6507. So when you talk about Catalyst 4K and 6K, all of them are chassis based switches like this. Those are giant switches. It's not easy to buy them. So only big customers would buy them, like 4500 series of switches or 6500 series of switches. Those are chassis. Those are not appliances. So again, there are two terminologies, appliance and chassis. All of you must be aware that what are the differences between appliance and chassis. So appliance is a fixed device where you have a fixed number of interfaces. You cannot insert more modules or something like that. Just like this. This is your appliance, this switch, right? There are two switches. Those are two separate switches. Those are not integrated actually. So one is placed on top of other switch, right? So those are fixed. I mean, see here, I believe this is 48 port switch, right? Here. And this switch is having only 24 ports. So it's a 24 port switch and this is 48 port switch. But those switches are fixed switches basically, where you cannot install more modules and something like that. You cannot modify a lot. But if you look at the right side, this is called chassis. It's a big box where you have so many slots. Like if you really look at here, 1, 2. So at top, it has got your power supply bay and fans bay, right? So you have got fans installed there. You have got power supplies installed there. And it has got many power supply if you look at there, many. So there could be 8, there could be 6, there could be 4. And then you have slots for installing your switch modules like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 slots. Some chassis would have only 3 slots. Some chassis would have only 7 slots available. Some chassis would have 10 slots available. Some chassis would have 12 slots available, where now you can count on the interfaces as well. Like each slot is having 48 ports. So imagine if you have got 10 slots available for these ports. So 10 multiplied by 48. So how many interfaces you have got? 480. So imagine that you can connect about 400 users directly to a single switch. So generally, we don't use these switches in local area network. Generally, you would see them in larger campus area network. Like you might see them in local area network, but in larger campus area network. So maybe in data centers, not in the data centers of service providers, because then they use some high-end switches, which are like Nexus switches and all that. But in the smaller data centers, you might see those Catalyst series of switches, Catalyst switches, because these switches would really have higher throughput. It has got like 2 supervisor engines here, like these two, where you don't see interfaces. I hope that you can see those slots available here. So these are the 2 cards here. This is one and this is second. You don't see interfaces, much interfaces there. Why? Because those 2 cards would work as a control plane. as a main CPU, main processing power of this switch. So it has got redundant processing units. So if one goes down, then other is available. I'm talking about the processing unit. Like if you talk about the appliance, on appliance you have integrated interfaces as well as their processing unit is available on a same appliance. But here in HSC based switch, you have got different slots for different purposes. So if you have got this switch here, let's say, so there are two slots reserved only for supervisor engine. Supervisor engine is nothing, but it is a main controller unit or main CPU, main processing unit. So there are two slots reserved for those cards only. But other than that, you have line cards. Line cards are like having switch ports available on it. Now you have got different line cards as well for different purposes. Maybe you would have line cards having copper interfaces, like you could see RJ45 ports are available. So you can insert copper RJ45 connectors as well. So you can make those connections. And if you come down here, right underneath this supervisor engine, there are only SFPs, SFP ports are available. Only SFP ports. So where you can insert only SFPs. So you can make fiber connections. So it depends, like what is your requirement. If you are going to connect only servers to this switch, then you should buy that line card which has only SFP ports available, not RJ45. But if you are going to connect your laptops, because laptop doesn't support the fiber optic or fiber connectivity at this moment while speaking, right? I mean, I don't think that any of you seen any laptop having that fiber connection. As of today, either your laptop is supporting only wireless connectivity or when it comes to wired, then only RJ45 connectors are supported. The copper connections, right? So if you want to connect your laptops directly with this switch, then you have to have a line card that contains only Ethernet ports. So that all depends on requirements, correct? If you're connecting only servers and then other network devices like routers and firewalls to this switch, then obviously you can simply rely on fiber optic ports or fiber ports. Then you should purchase line cards accordingly. Because you need to purchase, like, if you look at this switch, this chassis, it's got 10 slots available. So you need to install 10 modules. Out of 10, 2 modules are reserved for supervisor engine, that is for main processing unit. So you need to purchase 2 control plane unit, or I would call them like, basically their technical terminology is supervisor engine. Technically we call them supervisor engine. And then remaining 8 slots are available for your line cards. So there are 2 types of cards, sup card and line cards. Line cards are those cards where you have the switch ports available, where you connect your endpoints, like your servers, your printers, your cameras, your IP phones, like that. So those are line cards where you have those switch ports available. And those could be either RJ45, like Ethernet ports, or could be fiber ports. And you have supervisor engine. As I told you, like that's the main CPU of your switch. And why do we have those 2 supervisor engine here? For the purpose of hardware redundancy. In case one fails, then other will take over. So one will remain active, the other will remain standby. If active goes down, then standby will become active automatically. And that happens automatically by the way.
So SOOP cards are used for uplink or some like that.
SOOP card will be used for uplink as well as for processing your data, like maintaining your routing table. When you run a routing protocol, then it is maintained by the control plane of the device, right? So that is SOOP card who will be maintaining that routing protocol, whichever you are running, whether it is BGP, OSPF, EIGRP and all that. Your routing table RIB will be maintained by supervisor engine. But FIB, forwarding information base, CEF table will be maintained by line cards. Similar to appliances, you have got a control plane and then you have got a data plane. In data plane, you have a copy of FIB. In control plane, you have a copy of RIB, routing information base. Okay. Anyways, we'll talk about them later in more details, but I hope that you got some rough idea about it. And then you have got this 9800 series of WLCs, wireless LAN controller. So wireless LAN controllers are used for managing your access points. As I told you, like if you have got 100 or 1000 access point, because sometime you would see that you are having 1000 of access points, maybe more than that. So if you are managing all of your access points individually, independently, then it will, like in case of 1000 access points and managing them individually is almost impossible. I mean, nothing is impossible, but it's very difficult to manage all the access points independently. And that is why we have got a centralized controller for wireless infrastructure, and that is called wireless lane controller, WLC. Now I would take you through the Cisco's website so that you get more comfortable. So let me access cisco.com now. And you would also get more details around it, right? So cisco.com. So this is cisco.com, my favorite website, actually, right? And it should be favorite for each one of you since you all are learning the Cisco technology. If you go to products and services, just click there. And then if you go to networking, then you have explore networking, kind of option available, right? So just click there. And then if you scroll down, so you see that all these options are available, like smart switches, secure routers, exceptional Wi-Fi 7, industrial networking, mainly for manufacturing units. So those are industry grade devices, whether those are routers, switches, access points, or whatsoever. Software assurance. So you can see all the networking products, right? And then if I go back to product and services, you can also look at security based products, right? Like what all security based products are provided by Cisco. But for now, let's focus on networking. And under networking, let's focus on switches. Let's click on switches now. And then I'll click on wireless. First, let's talk about the switches here. So you see that you have got different types of switches, like small switches are there, then switches having RJ45 interfaces on it, switches having only fiber, the SFP modules. Like if it doesn't look like a RJ45, which means that it is SFP, it is containing SFP module, right? So like these switches here having SFP modules. These all switches having RJ45 ports. These switches are also having RJ45 ports. These switches having only SFP modules. And then you also have got this DNA center. So even on their website, they haven't updated it yet, right? Because they have renamed it as a Catalyst Center now. So from this Catalyst Center now, you can manage all these switches. For centralized management, we can use this DNA Center, also known as AKA, Catalyst Center. Anyways, let's scroll down. And if you look at the switches, then Cisco has divided all their switches into different categories based on their uses. For an example, if you want to use your switches at access layer of the infrastructure, right, then you have all these switches available. So it also has your Meraki switches, because at access layer, you can also use Meraki. But, one thing I would like to clear is that I'm not going to cover the Meraki technology here in this training. Right? We'll have some rough idea about Meraki, but not that much in details. But you could also use the Meraki switches at access layer of your switches. And I hope that everybody is comfortable with the access distribution and the core layer of the networking. In CCNA also, we learn about core layer, distribution layer, and then access layer. So nowadays, we do not use this 3-tier architecture. In fact, it is not really recommended to use the 3-tier architecture. In current scenario, or I would say nowadays, we are mainly focusing on the 2-tier architecture or collapsed core architecture, where we have got only access layer and then core layer. There is nothing like distribution layer switches. So we don't use them anymore. We don't use 3-tier architecture anymore. If it is a traditional network, then fine. If there is a traditional engineer, then fine. I can't really do much with that. But nowadays, there is no point of having 3-tier architecture.
In data center as well?
No, in data center, we are still using 3-tier architecture because of, performing load balancing and all that. So we are still preferring 3-tier architecture for data center. But for local area networks, we are not really preferring to have the 3-tier architecture. Nowadays, we are mainly focusing on 2-tier architecture, where you have got only access layer and then core layer. So we have combined core and distribution layer, right? So for access layer, you can use all these series of switches. So you can see C93. So this C indicates catalyst, right? This C indicates what? Catalyst. So catalyst 9350, 9400 series of switches. You have got some other 9300 series of switches. And then you have got these catalyst 9200 series of switches. Then you have core and distribution. For core and distribution layer of switches, you can use either this catalyst 9550, 9610, and entire 9500 series is there, and then entire 9600 series is out there. We have got multiple models under 9500 as well as under 9600 series. There are multiple models. I'll talk about them in a bit. Then for data center, you have got Nexus series of switches and then MDS switches for service providers, ISPs. Those are high-end switches. Those are not Catalyst switches. Those are Nexus switches and MDS switches. But still, they are also using Ethernet switching.
Mhm.
They are also using Ethernet technology. So technology is still same, but the capability of the platform has got changed.
So the command line is also different.
Command line, because the operating system got different. For catalyst switches, we use iOS XE. For catalyst switches, we are using what? iOS XE. Earlier, we were using Cisco iOS, but nowadays we use what? Cisco iOS XE. Whereas for Nexus switches, we are using NXOS. For Nexus switches, we are using what? NXOS. So that is a separate operating system. Now, let's say you are working on a Windows operating system and then suddenly you moved on a Linux or like maybe Red Hat or Ubuntu type of operating system. So there are differences. But after all, you are creating files and folders, whether you are working in Windows or maybe you are working on Ubuntu. You are creating files and folders only. Similarly, you are doing the same stuff, whether you are working on Catalyst switches or you are working on Nexus switches. But doing the same work, the command syntax would be, for doing the same work, the command syntax would be different. Then you have got embedded series. I think they have not provided any series as of today. Like you will have to click on this link to look at the embedded series of switches. Those are kind of smaller switches that you would find there. ESR 9300 embedded switch for IoT, like you can install those type of switches on your tanks and all that. So those are military grade devices basically. Smaller devices, but military grade or industry grade switches, I would say. Anyways, industrial Ethernet for your manufacturing units. Like you see IP66, IP67 rating. So if there is a water, still those devices would keep working. Like
So, sir, embedded one, it is for only defense purpose, or
yes, that is correct.
okay. Apart from that, we can't use that.
No, it's not like that you can't use them, but that is where you would like to have them, the embedded system. Now you also have industrial Ethernet for manufacturing unit. So like you're doing mining, coal mining. Now under mining, if you need infrastructure, right, network infrastructure, then you need to have those type of switches there. There is always water leakage somewhere under mines, right? You need to have those devices. So that is where you would use these type of switches. Maybe if you have got these oil and gas fields, right, where you have got extreme heat or extreme low temperature, you're having nuclear reactors, or you have these wherever you have got manufacturing type of things, you have got plants, different types of plants, where temperature can go extreme high or extreme low. That is where you use these types of switches, right? And for a small business, also you have got the options available. So you have got Meraki, you have got Catalyst 1300, 1200. Those are very small switches, very, very small switch. And then finally, you have got network management. So how you can manage all your switches? So you can manage your switches using Catalyst Center, as I told you before. That is an on-prem solution, right, which you can purchase from Cisco and you can install it in your own infrastructure, right? And you can manage all your switches from there. So it's a physical device. But also you can use what? Meraki dashboard. That is a cloud-based technology. Completely cloud-based technology.
So basically, this one is the hardware controller.
And this is a software. I mean, it is also a software controller, right? But you're buying a hardware to use it. It is installed on some of hardware, right? But Meraki dashboard is accessible through the internet only. It is a cloud management network, right? So it's a cloud-based service. And this is a on-prem service. Also, nowadays you can also install Catalyst Center in AWS as well. That option is also available, but we don't really prefer to use AWS for the installation of the Catalyst Center. Why? Because Catalyst Center requires a lot of resources. Like, just to give you an example, to install one Catalyst Center, you would require 48 CPU cores, 256 GB of memory, and around 3 TB of storage. Now imagine that if you are using that much resources in AWS, then how much billing you are going to get every month, right? So that is why most of customers do not prefer installing Catalyst Center in AWS cloud. They usually have it on-prem. Whereas Meraki dashboard is totally cloud-based technology, right? Anyways, let's come back to the Nexus.
Costly than our traditional one now.
Yeah, absolutely. See, features comes with cost.
Yes.
If you're buying extra features, then there has to be cost involved then. You have to bear that cost.
And Just for curiosity, I'm asking. In further in future, so might be this networking goes on that cloud network only, no? Or not?
It's already there.
Means right now it's going on
It's
only,
already there.
but
So
we
it's
have
already
that.
there. Why I'm saying is,
Mm.
like this Meraki dashboard is not only managing your Meraki switches, but also managing Catalyst switches from
Mm-hmm.
cloud. And then Catalyst Center is already managing all your Catalyst switches and wireless infrastructure, right? You can also create the SDA fabric if needed. And that's for Cisco. But if you take an example of, let's say, Aruba Central is already there, right? So
Yes.
Aruba is also providing you a cloud-based controller from where you can manage all their switches and wireless infrastructure, right? Similarly, it goes with Extreme. Extreme is also providing you a centralized controller hosted in cloud, and from there you are managing all their switches and access points like wired and wireless infrastructure, right? So you take an example of any vendor, they all have got cloud-based controllers and managing all their devices from there only. So don't say that it's a futuristic technology. It's already present out there in the.
No, but in the future, might be it will boom.
No, I mean, it's already booming, like
Mhm.
if you are buying devices from Cisco, Cisco is already, proposing customers to either go for Meraki or maybe with Catalyst Center. I would say that not everyone is really, like, not all customers are opting for that, but looking at the provided feature list, right? Most of the customers are now tilted towards moving over to cloud-based technology or cloud-based management, or maybe this type of Catalyst Center. So already customers have started adopting this new technology. Don't worry. We engineers must learn these technologies to survive. If we want to survive, then we must learn all these SDN-based technologies. So when I say SDN stands for software-defined networking. So when it comes to local area network, then we have got these two technologies like Meraki dashboard and the Catalyst Center. And when we talk about the wide area network, then we have SD-WAN, where we have got that vManage and all that. And when it comes to data center, then we have got ACI. So basically, Cisco is having SDN-based technology for each and every section of the network, whether it is local area network, whether it is a wide area network, whether it is a data center. For each section of the network, they have got SDN-based technologies. Or they have got SDN, software-defined networking. Yes, let's come back here. I would like to go through some of these switches so that you get more details about the switches and you get more ideas about it, right? So if I click on, explore access switches or see all switch. So let's say if I click on see all switches, then it would give me this list of all these switches, see that. So you have got some smart switches here, and you have got some modular switches, and then you have got, so those chassis are also known as modular switches. Those chassis are also known as modular switches. And let me show you that. So if you talk about 9400, let's say, so see, this is how it looks like. And then you have multiple options, multiple models. You have got 4-slot modular chassis, which would have only 4 slots. Then you have got 7-slot modular chassis, where you would have like 7 slots available. Then you have got 7-slot modular chassis. The cost of the chassis would be depending upon like which chassis you are buying. So if you are buying like 4-slot modular chassis, it's a smaller one. So the cost will be lower side, at lower side, the cost will be lower for it. For 7-slot modular chassis, obviously the cost will be lower as compared to 10-slot modular chassis. But just look at this. If you have 4 slots modular chassis, which means that you would get only 4 slots where you can install only 4 modules. One of them would be for main CPU, and remaining 3 would be for line cards. For 7-slot modular chassis, it will have like 7 slots available. Like if you look at this chassis here, right in front of you, this is 7-slot chassis. You can count them: 1, 2, 3, 4, 5, 6, and 7. So in this 7-slot modular chassis, your slot number 3 and slot number 4 is reserved only for supervisor engines. Supervisor engine, I hope that now you understand that it's the main CPU. It contains the main CPU. It's a main processing unit, right?
So one question.
It is responsible for that chassis now. These two
Sorry.
supervision engines.
I'm sorry, say it again.
So I'm trying to say these two engines. This is responsible for whole chassis now.
Yeah, absolutely. Whole chassis.
It is like
Main processing unit, sir.
hmm.
It's a main processing, main CPU. Like if it is not there, then you cannot access your console as well. Your switch will not be
Mhm.
booting up.
So if supervisor engine is not there, we cannot use it as a
You
temporary
cannot
light.
use your switch at all. Your switch will not be booting up without having the supervisor engine. It's a main controller unit or main controller of the switch. You install the images on the supervisor engines only.
Okay, okay.
So your switch will not be booting up if supervisor engine does not exist on your chassis. Chassis is nothing, it's a steel box without installing modules on it.
Okay.
Like if you do not install the line cards, how can you connect your lane user machines to the switch, to the chassis?
And if we talk about slots, so we do not need to calculate that above one and that fan and power supply one up.
You have to. You have to.
Mhm.
So, remember, if you are going to have a fully loaded chassis, then
Hmm.
you should load it fully. Like for an example, if you have got the 8 slots or maybe 4 slots for your power supply, then you should plug them all. You should insert all your fans. You
Hmm.
should insert all your power supplies there and then plug them if you are going for fully loaded chassis. But if you're not going for fully loaded chassis, let's say for this 9407, you're going to use only 3 line cards. You're not going to use let's say 5 line cards, or maybe you're using just 2 line card and one supervisor engine, just one. You don't want any kind of redundancy, or you don't have enough money to buy those additional modules, right? Then you don't need all those power supplies or that many fans. Then you can reduce them. You can reduce the count. Now, chassis, I hope that you got to know that how many different types of chassis you have got. Then supervisor engine. See, you have different types of supervisor engine, and all of them have different capabilities, and cost will be applicable accordingly. So like if you look at this supervisor engine, this has the most throughput among all these models. So it has a throughput of 480 Gbps. And this model of supervisor engine, which is 9400X Soup 2, this is 9400X Soup 2 XL. So their models are different, and accordingly their throughput will be different, and the available interfaces will be different for uplinks. Like here you can see 100 gig are supported. 100 gig are supported here. It supports 40 gig and 10 gig only. And here it supports 40 gig, 25 gig and 10 gigs. Make sense? So according to your requirements, you would pick up the supervisor engine, right? Then you have got line cards. You have got so many different types of line card. Like you have got copper line cards, 48 port, 1 gig data, copper, and some of them are PoE as well. 60 watt PoE and then 30 watt. If you have got your IoT devices that would require 60 watts, then you have to purchase, you don't have any other option other than this. You have to purchase this line card. But if you have the IoT devices like your cameras, your IP phones that can work with 30 watt power, then you can purchase this line card. And if you know that, okay, you don't have any IoT devices whom you are providing power from the switch, you don't need any PoE switch then. You don't require PoE line card. Then you can buy this. And cost will be different for each line card. Then you have got this 10 gig SFPs. So this line card would have only 10 gig SFPs available. 24 ports, 48 ports, 28, 24, and then 48 again. Then 94X copper line cards. So even 90 watt PoE. This is again for copper, which means RJ45. Then fiber line cards. Even you have fiber line card having supporting 100 gig, but it would have only 12 ports. For 40 gig, 4 ports, 100 gig. So you can't say that, hey, I need a line card that has got maybe 24 100 gig ports. How can you do that? 100 gig. The overall throughput is like 400 gig, let's say. And now you are saying that, okay, give me a line card having 24 ports and supporting 100 gig. How is it possible? 2400 gig then. The throughput that you would require is 2400 gig. So 400 gig would not work. That is why this line card has got a limitation of 4 ports of 100 gig only. So all those options are available. You need to pick and choose. But this is chassis. So chassis is nothing. It's a steel box. It has got slots, many slots available, depending upon like which chassis you purchased. Maybe 4-slot chassis or 7-slot chassis or 10 slot chassis, 10 slot modular chassis.
While designing the solution, we also have to take care how much throughput is there, and then we
Absolutely,
have to
absolutely.
put the
And that is why only experienced people can do it. This designing work can be done by the experienced people. Like if a fresher is working on this stuff, then fresher doesn't know anything about the requirements, like how, we calculate the requirements and then how we take the decision that which chassis would be enough for us, which line cards will be enough for us. And you also have to forecast the futuristic requirements. So as a fresher, obviously it is next to impossible to do the sizing work. Sizing work cannot be done as a fresher. Even if you have got an experience of 5 years or maybe 6 years, still you cannot do the sizing work. You should have an experience of, let's say, 10 years or maybe 15 years. Then only you can start working on the sizing stuff. But at least being a engineer, we should know that, okay, these are the different types of switches that are. And this is how we take the decision that whether we should pick up this line card. So you should have an idea, right? So that is why I'm discussing all these things with you now. Now you can also view the data sheet for this series of switch. So basically I opened up this 9400 series of switch. If you look at the data sheet, like view data sheet, it will give you a complete information about these hardwares. 360-degree view, look at this. It seems like something is not working. These are the line cards. This is overall chassis. Anyways, this product is built for security, IoT, and cloud. Software subscription, like which obviously you should buy license as well, not just hardware. So when you buy a laptop, you don't just pay only for hardware, but also you need to pay for Windows operating system. And not just for operating system, but also for, let's say, Office 365, there is a different subscription for that. Sometimes it comes as a bundle. Sometimes you need to purchase it separately. So it depends. But point is, like, when you are buying a hardware from Cisco, does not mean that you would get everything there. No, you also have to subscribe the license to use the features. And not just license, but also you need to subscribe the tech support. If you don't subscribe the tech support from Cisco, you don't get support from Cisco, just in case if you fall into a trouble.
warranty.
Yes.
So we have to purchase hardware also.
You have to purchase hardware. You have to purchase hardware. You have to purchase licenses to use it. And also you need to purchase the support.
Warranty also, by default, they are not giving any warranty. No? We have to purchase it.
There's some amount which is required to, we need to pay to Cisco in order to get some warranty. But that warranty is a little different, like some depending upon like which type of warranty you have purchased from Cisco. Sometimes they will give you a warranty that if in case switch becomes faulty, we will get it replaced within 4 hours, within 24 hours, within 48 hours. That type of warranty is also available by Cisco. So even if they have to, let's say if your plant is somewhere at remote location and if they need to take a flight, they will take a flight to deliver the switch. So that is why the cost is higher for all those types of warranties. Anyways, so now product highlight, you can see that up to, like Intel 2.4 gigahertz CPU, then SSD storage and all that. You can see all that information. Right. So it is providing all the information that it supports. So it can have up to 392 ports of 1 gigabit Ethernet. It can have up to 392 10 gigabit Ethernet ports, right? And it can have up to 168 ports of 25 gigabit. If you increase the bandwidth, the number of interfaces gets reduced. If you have 100 gigabit, then up to 36 ports. 400 gig uplinks plus 3200 gig line card ports, because one line card can have one could have like maybe 4, some line cards could have 4, some line cards maybe could have bigger than that or more than that. I believe it was 4 only, if I can recall it. Like one line card could have only 400 gig ports. But if you are having a chassis of 10 slots, then 8 slots will be used for line cards. So 8 multiplied by 4, that becomes 32. Then up to 384 ports of non-blocking 10 gig 5 gig RJ45 ports. Then PoE, 90 watt, 60 watt, 30 watt. All those capabilities are supported by this switch. Depending upon your requirements, you can pick up your line cards, right? And then if you keep rolling down, you would get more information, right? About security, about resiliency, high availability. And then SSO is a stateful switchover. Like if one of the one of the supervisor engine goes down, then as I told you, one will be active, the other one will remain standby. If active goes down, then standby becomes active automatically. And on top of it, you can also implement SSO, stateful switchover, where what happens is that if active unit has got a number of routes in its routing table, then it will share all that information with the standby unit as well. If active unit is having something in its fib, the same information would be shared with the standby. So if active fails, then standby is already having all the information in advance, and it can keep forwarding your data seamlessly. So there will not be any outages occur while one of the supervisor engine is going down. So even there is a hardware failure, but still there is no outage in your environment, right? So that type of high availability is provided. Okay, so you can keep rolling down. I'm not going to read it line by line. It is up to you, but it will give you all details here. So there are 3 different types of chassis, as I told you, 4 slot, 7 slots, and 10 slots chassis, modular chassis, right? And then you can see that how many slots these chassis have got. So C9404 will have 4 slots. 9407 would have 7 slots. 9410 would have 10 slots. And how many line cards? Okay, so it seems that even for 9404, they have reserved two slots for supervisor engine. So with this chassis, you can have 2 line cards, right? 2 line cards and 2 supervisor engine. With this 9407, you would have 5 line cards and 2 supervisor engines. With this 9410 chassis, you would have 8 slots for line cards and 2 slots for supervisor engines. Make sense? So each chassis has got 2 slots reserved for supervisor engine, and dedicated supervisor engine slots are there. So in 9404, you would have 2nd and 3rd reserved for supervisor engine in the middle. So 1st and 4th can be used for line cards. And then in 9407, you would have 3rd and 4th slot reserved for supervisor engine. Whereas for 9410, you would have slot number 5 and 6 reserved for supervisor engine. And you cannot interchange that. You cannot install the line card where supervisor engine was supposed to be installed. You cannot install supervisor engine where line card was supposed to be installed. That is why they have reserved that. So slot number 2 and 3 in this chassis is reserved for supervisor engine.
We cannot modify, no, sir?
No, you cannot.
Purchase.
That is why they are telling you the reservation, right? Dedicated.
So in chases, we are using this models only, C9400 and this one. So it is varying, or it is a fixed one? We can change accordingly that.
I'm sorry, say it again.
So I'm trying to say, sir, that switches that we are using in chassis. So for that, it is fixed one that they are using the models, or is there any different we can take it? Like
No, there are
C9400.
many models, right? So if you look at there is a 9404 model, right? And then this is 9407 and this is 9410. You cannot change it. You can't say that, hey, Cisco, can you give me like a chassis which is having like 15 slots? You cannot customize it. Whatever is available, you can pick it from there only. So these are the 3 different types of chassis within this model, 9400, right? But if you go back and if you choose any other model, like if I go back here and because 9500 is also there and then 9600 is also there. So if you look at here, 9500 series of switches are also there. But mostly you would see that people are using 9300 and 9200. Mostly people are using 9300 and those are appliances. Those are not chassis. Those are appliances. Like those switches will look like this. Those are completely appliances like this. And you have got different models again. So you have got a copper model. You have got fiber models. You have got high performance models. you also have got a model that supports PoE for up to 90 watts. And then you have also got a model that supports PoE with 60 watts, 1 gig models, 9300L models, and then LM models. Make sense? And this is how it looks like. I can also play this video. So it has got like multiple fans, and then this is how it will look like. We also have got these switches in our labs. If anybody wants to see, you can also see that from the glass. You would see these 9300 series of switches installed in our lab. So you can pick these different models, and then again you can read the data sheet. Datasheet will give you more details about all these platforms under this series. So each series has got different models. Like 9300 is a series. Under 9300, we have got different models. Similarly, 9400 is a series. Under 9400, we have got different models.
It is like that we are buying some car, so they are having the different models, ZX, that like that we have over here.
Whichever and however you want to compare it, it's
No,
your
no, no, I'm
choice.
just
But
comparing.
yes,
So get that
nowadays,
understanding.
especially with these electric vehicles, yes, you can compare
Uh,
it that way. Okay. Anyways, I hope that now everybody is comfortable that we have got all these Catalyst series of switches, and especially this 9K series. If I talk about 9K series, then you have got 9200, 9300, 9400, 9500, and then 9600 series of switches. That is Catalyst 9K series. But apart from that, you also have got like those layer 2 switches. Let me tell you those. Like earlier we were using 3800, 3700, 3600, and all that. And these are the industrial Ethernet switches, i.e., industry grade switches, rugged series. Even if you throw those switches away, nothing would happen to those switches. Are very expensive. And for a small business, you can also see those switches here, like 350 series of managed switch. And there are some unmanaged switches as well, like D-Link from Cisco. So those unmanaged switches are also available. And then Nexus series of switches. I obviously don't want to talk about the Nexus switches at this point in time, but Nexus switches are also there. And then Meraki switches are also there. Cisco Meraki cloud managed switches. So you have got them. And yeah, I mean, so you could see based on based on your uses as well. Like for an example, if you want to look at the compact switches, which are smaller switches, by the way, right? So you can see them, access layer switches. Then for campus lane switches, core and distribution, data center switches. So you can see all of those switches based on those categories. But you can also look at your switches based on series, like 9200, 9300, 9400, 9500 series of switches. So I hope that now you got some ideas around the hardware specifications, right? And obviously it will take time for you to digest all this information, and you should visit this website, like at least visit this website every day for a week or so, or maybe for 10 days. And then you would get familiarity with all these models. So if you want to become familiar with all these models, then you have to visit this site. Anyways, apart from this, you should know about the operating system. You got an idea about the hardware. What about operating system? Like we bought the laptop hardware. We don't know yet whether we are going to use Windows or we are going to use Ubuntu or whatever, like SolarWind or whichever operating system you want to use. So we must be knowing the operating system. So when it comes to Cisco, then we are using Cisco IOS XE nowadays. We are using what? Cisco IOS XE.
XC will also have different versions.
Yeah, absolutely. So when it comes to Cisco IOS XE, we have got different versions. Like when it comes to Windows, so Windows XP was there, then Windows Vista was there, then Windows 10 came in, I believe. Then nowadays we are using Windows 11. So in similar way, IOS XE has also got different versions. And we can also look at that. Like for an example, there is a site software.cisco.com. You go there, then go to access downloads, and then we could look at the operating systems as well. So for an example, if I'm having a 9300 series of switches, let's assume that. So you go to browse all, by the way, browse all, and then in left side, you should have switches. So routers, and then you have got switches. Then you have got like blade switches, campus lane switches, and all that. So let's say campus lane switches for access layer. So you have got 9350, and then you have got 9300 series, 2960, 3560. So let's say I've got 9300 series of switches. So I'll click there, and it will ask for the model that you have selected series, fine. But now tell me model, which model you are having. So let's say you had 9324. Yeah, let's have this. Let's say we had 9300X24HX switch. Let's assume that that's the model that we are using. So click there, and then it will give you its IOSXE software. So click IOSXE software. Now, if you look at the gold star image, this yellow star, do you see that? This star image there. So that's called gold star image. So as of today, Cisco is recommending their customers to use this version 17.15. But they also have launched version 26 because now Cisco has decided to launch the versions based on the year, the current year. So if it is 2026, then they will have version 26. If it is 27, then they will have version 27. But until now, they were having this version 17, and under version 17, you can also see that we have until version 17.18. But now they have stopped it until at 17.18. Then after they have released now version 26. So 26.1 has came in. You can see that. So maybe now they will introduce 26.1.2 or something like that, 26.2, 26.3 in year 2026. But in year 2027, they will release another version called 27. So you should look at the gold star image, by the way. So if Cisco says that this is gold star image, which means this is the recommended version by Cisco. So we should use this image, like we should download this image from here, and then we should install this image on this platform, this model. Does that make sense? That is how we could download the images. Now you cannot download the image if you did not purchase the hardware from Cisco. Cisco does not allow anyone to download their software images. So there is an account that we call smart account. So you need to create your smart account. So when you purchase anything from Cisco, any device, they kind of update your smart account accordingly. Let's say you purchased 2 switches. So that information will come to your smart account. Now, when you log into Cisco website using that smart account credential, then it will allow you to download the images only for those 2 switches, not for any other switch, not for any other technology. That kind of restrictions that they have applied. If I want to download this image, I cannot download it. Like if the moment I click on download button, it will tell me, hey, login required. And the moment I log in using my credentials, and if Cisco sees that I do not have the proper alleviation, or if I'm not allowed to download that image, it will not download. It will not let me download this image. So it's not like you can go and download any image from Cisco. It doesn't work in that way. Earlier, it used to be like that. Like earlier, it was possible to download any image from the Cisco's website. Like if I talk about 10 years back or 15 years back. But now Cisco is restricted. Like, okay, you are allowed to download image only for those devices that you have purchased from Cisco, not for any other devices. So we are using, so I hope that everybody got to know that the operating system is IOSXE that we are going to use on Catalyst switches. And before IOSXE, we were using normal Cisco iOS. And iOS was released by Cisco until version 15. So if I go back here, and if I go to access switches, and if I go to those older switches, let's say 2960, that layer 2 switch, and let's say this is a layer 2 switch and iOS software. So you can see that version 15 was there. The most latest version was version 15 in case of iOS. But nowadays, Cisco has stopped working on iOS. And that is why nowadays all their routers and switches are using IOSXE. So Cisco is releasing only IOSXE nowadays. So Cisco has stopped using normal iOS. Now remember, when it comes to Cisco, for switches and routers, obviously we are talking about IOSXE. But as I told you, like if you are using Nexus switches, then they will, then you will have to use Nexus operating system and NXOS. So for Nexus platform, you have got a different operating system.
So by default, if you purchase the hardware, there is no operating system present in it.
No, I mean, when you purchase it from Cisco directly, then there is a operating system present on the devices. But it is possible that it is using a lower version. So you may have to upgrade it. But generally, Cisco is providing you hardware with operating system pre-installed on it. So what I'm saying, what I'm trying to make you understand is that for different devices, there could be a different type of operating system. Like for firewalls, there is a different operating system. Now, Cisco ICE is a different device. They have got a different operating system for Cisco ICE. And for Cisco Web Security Appliance, WSA, they have got a different operating system. So for different devices, they have got different operating system. But for Cisco routers and switches nowadays, they're using only Cisco IOS XE. Now the command syntax in Cisco iOS and Cisco IOS XE is same. That is a good thing. So if you learn Cisco iOS in CCNA, then command syntax is going to be same in Cisco IOS XE as well. So there will not be any differences for whoever has worked on Cisco iOS. So the command syntax is going to be same, even in Cisco IOS XE. Even iOS installation, the upgrade process and everything is also same as normal Cisco iOS. Any questions?
Sir, if just for curiosity, so right now consider we have the version 15.0, that image one, and we need to set it on 15.2. So is it possible we can directly jump on that, or we should go step by step?
So thing is that generally this is the question that you should ask for, or this is the question that you should ask to Cisco TAC team.
Mm-hmm.
So there are advisories that you should read before upgrading your devices. But in Cisco, generally, it is allowed to jump. Let's say if you are using iOS XE version, I'm not talking about the iOS anymore. I'm talking about the iOS XE. So let's say you are using 17.1 and you want to jump directly on 17.15, you can do that. You can do that. In Cisco, it is possible, but not for all devices. For iOS XE, yes, it is possible, but not for all devices. Like for an example, if you are using Cisco ICE, in ICE, you cannot jump in that way. You have to go step by step. You have to follow this. So my point is, since you are asking this question to me, so my answer would be that you should always consult with Cisco TAC before doing anything, before taking any decision. There is an informative ticket that you can always open with Cisco TAC. Ask them that this is your plan. You are planning to upgrade your Cisco switch from 17.10 to 17.15. Is it doable? Is it feasible? Or I shall upgrade it first to 17.12 and then 15 or whatsoever, right? You should consult with Cisco TAC team. So you should not take the decision by your own.
Yes. So just for.
I hope everybody got this idea now. And now let's go ahead. So types of ports on catalyst switches. Remember that when we talk about the catalyst switches, now I'm talking about the catalyst switches. I'm not talking about Nexus switches. I'm just talking about the catalyst switches. So when it comes to catalyst switches, whether it is your 9200, 9300, 9400, 9500, 9600, or those older series of switches like 2960, although 2960 is a layer 2 switch, so obviously all ports will be switch ports, layer 2 ports. But even if you talk about 9200, 9300, 9400, these all are layer 3 switches. But still their switch ports, their ports will remain or are by default switch ports. Like by default, they all have layer 2 ports. So when you talk about catalyst switches, all their ports are by default layer 2 ports. If you want to convert their port, then you have to convert it manually. And that is where you use this command, no switch port, to disable the switch port on the interface. And that's how the interface becomes layer 3 interface. I hope you run this command in CCNA. If not, then we will be running this command here in CCNP. So no switch port command, you can always run it on your switches, one of the interface or on multiple interfaces. But then your switch must be a layer 3 switch. If your switch is a layer 2 switch, then how you can have a layer 3 port there? Let's say you are working on a layer 2 switch and then you are trying to disable the switch port on its interfaces. How you can do that if it is a layer 2 switch only? But if you have got a layer 3 switch, let's say you have got 9200 or 9300, 9400, any of that, still their all ports are layer 2 port. You want to use any of the interfaces as a router interface, as a layer 3 port, then you have to disable the switch port on that interface. You go to that interface mode and run this command, no switch port. That's how switch port gets disabled. Make sense? So we will do it tomorrow, like how to disable switch port, how to enable it back, what happens when we disable the switch port on the switches in background and all that kind of stuff. So we will look at the extended range of VLANs. We would look at the standard normal range of VLANs, SVI, and all that kind of stuff. So that we will cover tomorrow, not today. But I hope that all of you must have got some ideas about the hardware platforms and all that. So let's continue this tomorrow then. For online, thank you very much. And what I'm saying is that each switch would have its console port, as well as it would also have its management port. Earlier, like if you look at the older series of switches or older switches, those switches do not contain a dedicated management port. But when you look at this new 9K series, each switch would come with its dedicated management port as well as console port. So that is good thing, especially from a management perspective, that we are having a dedicated management port. And then these are the slots where you can install the SFPs, At right side, you must be able to see them. All of these ports are RJ45 ports, so you can plug the RJ45 connectors to all these switch ports. So you can use copper cables. But then if you even have got fiber optic or fiber cables, you can also connect them by installing the SFP. So you will have to install the SFP here. Now, how does the SFP looks like? Then it is a different story altogether. So let me also show you that how SFP looks like. So I'll show you the SFPs. Like, see, these are the few slots here again, that you can insert on your, these are the network modules that are available for this 9300 series of switches. So this is for RJ45 again, and this is for probably fiber optic connections. So you can see different types of slots are available. And then I would like to show you the SFPs. These all are the power supplies and then fans. And when it comes to SFP, so you have basically two different types of SFPs. One for the copper connections, and the other one is for the fiber connections. See, if you have already worked, then you don't need to understand this. But if someone is really, never touched the SFP, then it would be good for them to look at the SFP images. So let me see if I can find them. Otherwise, I can Google it easily. Cisco SFP images. So this is how it looks like. So it's a dual mode SFP if you look at this. There are some SFPs which are also known as single mode SFP. So generally, you would see that for short ranges, we are using dual mode SFP. So this is how it will look like. So you can see this image now. This is how it will look like. So this is what you need to insert on those slots. And you have to connect your fiber cable over here. So you have like two cords coming in. Then each cord will be inserted in these slots.
The fiber optic cable have one slot, like our fiber optic Wi-Fi comes with one wire which is connected with the device, and another
That is single mode SFP.
Okay.
So there are two types of SFP are available in the market: single mode and dual mode. So this is dual mode SFP, where you have different cable for RX and TX, different current connectors. So this is how it will look like. So it's different than single mode. This is multi-mode SFP. So for short range, we use this multi-mode SFP. For longer ranges, we use single mode SFP. Like when you get a broadband connection, you get only one connection there, one connector, because that is for longer range. But in data centers, we use multi-mode SFPs. So this is how it looks like. There is a lock here. So you need to take it down if you want to plug out this SFP from the switch slot, because these SFPs will need to be installed here. Let me show you those ports available here. So for an example, if you have got, let's say these switches, right? So at right side, you can see that those SFP modules are available, right? So you can install the SFPs on your right side slots. So you install the SFP there and then you plug the cable. And when you purchase a switch, from Cisco, you need to buy SFPs separately. There will be separate billing for SFP, and Cisco SFPs are expensive at same time as compared to, the other vendors which are available in the market. But then Cisco does not give you warranty. So let's say on Cisco switches, if you are using the SFP from some other vendor, let's say some Chinese vendor, and something is not working, Cisco TAC will not provide you support. They will first ask you to replace the SFPs with Cisco's one, and then they will provide you the support for that. And this is how they have designed their hardware actually. So you should not be using the SFPs on Cisco switches from any other vendor. I mean, it doesn't mean that it doesn't work. Like I have personally used from many different other vendors, on Cisco switches. Like once I had a SFP for my servers from HP that I used for Cisco, and also there are some players in open market from China. They are also selling their SFPs, and you can install those SFPs on any device, whether you purchased your device from Cisco, from Juniper, from Fortinet, from Palo Alto, doesn't matter. Those SFPs work for all these OEMs, but sometimes your devices does not detect those SFPs. So maybe that SFP is faulty, or maybe the port on your device, on your hardware is faulty. Generally, the interface, the port on your hardware, on your switch, on your firewall will not be faulty. In most cases, your SFP will be faulty. But I hope that everybody got this idea that SFPs would require to be installed here on these slots available on your switches. So if you go back to platform details, you can see that we have got different platforms here. So under 9300 series, we have got different platforms. So you can see 9300X, 12Y, 24Y, 24T. So you have got 24 data ports, no PoE. But if it is 24P, which means 24 ports PoE plus, you can identify it that way. So there are many platforms, many under 9300 series. And remember, this 9300 is the most famous one among all of your switches. So nowadays, mostly customers are using 9300 series of switches. Anyways, as I told you, like I'll begin with some labs also. So let me try to access a lab now. So I already have access to that. I'm already accessing the virtual 9K series of switch. So let me try to access the console of this switch now. So I've got like 3 switches here. Close this once. I'll log in onto, this switch 1 first. So it's a 9K series, but it is a virtual switch. It's not a hardware switch. You would not be able to get the access of these switches, by the way, and you cannot even install them on your local laptop. Because to run one switch, just one switch, you would require like 16 to 32 GB of memory. So it's barely possible to run all these switches on your local labs. But anyways, this is virtual switch. If I say show version, look at the version that I'm using here. So I'm using what? 17.10. But if you remember, the gold star image was 17.15. And then most latest version was version 26. Within 17, it was 17.18, most latest one. So this switch is up for 1 day, 14 hours, 38 minutes. If you run this command once again, show version, you get so many details. Like first, you get to know that which iOS XE version you are using. Second, you also get to know that for how long this switch has been up. And it also says that system returned to ROM by CPU usage due to memory pressure exceeds threshold. So maybe it got restarted, rebooted. And why it got rebooted, that reason is also given over there. It is also giving you system image. Last reload reason was CPU usage. So it was rebooted automatically because of the higher CPU utilization. Then also you can see that which license you have got here. So if you look at here, so basically the license that we have a DNA advantage. I'll also talk about the licensing. Even before I move further, I would like to talk about the licensing. So now you can also look at the serial number and everything, So this is the system serial number. This is the system MAC address. And you would always get the motherboard assembly number, motherboard serial number, motherboard revision number, and all that kind of information if it was a hardware device. If it was a hardware device, then you would get all these numbers. But since I am using a virtual switch, so obviously I do not have, because there is no motherboard for this switch. It is a virtual switch. And also you can look at the platform. It clearly says that it is a virtual switch. Correct? So that's that. And currently its configuration register is 2x0x2102. I hope that you are aware with these configuration register values, right? 2102, 2142. I believe that in CCNA you must have performed some password recovery type of thing, and that is where you would require to modify your configuration register values. So this is your default configuration register value on this switch. All right. Now there are some other basic commands as well apart from show version. Like you could also look at show inventory. This is one
Hello?
of the important command. Yes, go ahead. Show inventory. That gives you a lot of information about your platform, about your hardware. So, like you can look at the serial number, and then in case of if it was a hardware device, then it will give you complete detailed information about your hardware. Then I would also like to run some other commands here on this switch, such as show VLAN brief. As you know that this is the command that we even used in CCNA to look at that how many VLANs does exist on your switch. So you could see that I have got only one VLAN, and that is a default VLAN. That is a VLAN 1. So you must be knowing that VLAN 1 is a default VLAN, correct? VLAN 1 is a default VLAN. So that is the only VLAN that currently exists on your switch. And by default, all your interfaces are member of VLAN 1. Then also you can look at the interfaces. Show IP interface brief, that would give you a complete idea that how many total interfaces that you have got on your switch. So I've got one management port available on this switch, which is gig 0 by 0. That is a management port. And by default, you could see that your management port is set up to obtain an IP address from DHCP. So DHCP services are by default enabled on your management port. So this is your management port. But apart from management port, you have got your data interfaces here now, like gigabit Ethernet 1 by 0 by 1 until 1 by 0 by 8. So currently this switch is having like 8 physical interfaces available. 8, correct? And 2 of them I have already converted into layer 3. And that is why those 2 interfaces are not member of VLAN 1. If you look at the VLAN 1, those 2 interfaces are not member of that VLAN because I already converted them into layer 3. You must have seen IP addresses were already allocated by me. So these are not fresh switches. There is some pre-configuration available on these switches, but I'm just using these switches to make you, comfortable that, even in iOS XE, the command syntax is same as Cisco iOS. So even if you are using Cisco iOS switches, from learning perspective, it's gonna be same. Okay. All right. Then next thing is switch port. I told you that by default, you can take an example of any switch. Their ports are by default switch port.
Sir, one question. Hello.
Yeah, go ahead.
Sir, so on all the switches, the gigabyte 0/0 will be the management port by default, or we can set any other port as a management port, or how?
No, I mean, see, by default, gig 0 by 0 is a default management port on new switches. Like if I talk about the 9K series of switches, like if you have ever worked on 9300 series of switches, they have a dedicated gig 0 by 0 interface, and that is used as a management port. Make sense?
Right.
Now, if you don't want to use this port as a management port, and let's say instead of using this physical port for management connectivity, you want to create a management VLAN, and then you want to assign an IP address to that management, that is also possible. So I hope that now you understood this. Anyways, I was talking about the switch ports. So I'll show you gigabit Ethernet 1 by 0 by 3 until 1 by 0 by 8. All these ports are switch ports. In fact, 1 by 0 by 1 and 1 by 0 by 2. These ports were also pre-configured as switch port, although I changed them by making some configuration onto switches. But if you look at now, show interfaces gigabit 1 by 0 by 3 and then switch port. So if switch port is enabled, then it must display to you. So what do you see? Is switch port enabled or not? It's enabled. If switch port is enabled, which means it is a layer 2 port. And on layer 2 port, if you try to allocate an IP address, it will not accept your configuration. So let's say if you go to 1 by 0 by 3, and then if you try to say that, hey, I'm going to assign this IP address 10.1.1, and then this is going to be my subnet mask. Would it accept your command? No. Why? Because it is a layer 2 port. If it is a switch port, which means it is a layer 2 port. Simple as that. Okay. So if he wants to allocate an IP address on a switch port, You cannot actually. So first you will have to disable the switch port, which means you will have to convert that port from layer 2 to layer 3. You will have to make it layer 3 port. To make it layer 3, first command would be no switch port. So this command now will convert your port into layer 3 now. So now this port will become similar to the interfaces available on your routers. So it's a layer 3 port. Now on this layer 3 port, if you want to allocate an IP address like this time it will accept that command. And yes, this time it did not give us any error message, any warning, any error message. So the command has got executed. Then you can say no shutdown, although on switches you don't have to put this command no shutdown, because on switches by default your interfaces are not administratively shut down. Although on your routers, like if you compare switches with routers, then on routers by default interfaces are administratively shut down. But that is not applicable for switches. Switches by default, all your interfaces are administratively on, administratively up. So you don't have to use this no shutdown command. So if I say show IP interface brief, you could see that now we have allocated an IP address on this interface gig 1/0/3. Now if I run the same command, like show interface gigabit ethernet 1/0/3 and then switch port, what does it say now? Switch port is disabled, and therefore it is working as a layer 3 port. So I hope that now you have understood the meaning of the switch port command. So we can use this switch port command to switch your interfaces from layer 2 to layer 3 and vice versa. If you say no switch port, then your port becomes layer 3. If you simply say switch port, it becomes layer 2 port, and it will remove the IP address automatically. Does that make sense? Do you find any difficulty so far? Any one of you? Now, one thing that I would like to tell you is that when you use this command, let's say show run interface gig 1/0/1, I also run that command no switch port here on that port, and also on gig 1/0/2 and also on 1/0/3. I disabled the switch port. That is how I converted that port into layer 3 port from layer 2. So your layer 2 port was converted into layer 3 by running this no switch port command. And currently switch port is disabled across all these 3 interfaces. But if you look at 1/0/4, that command does not exist on that port. So it should still remain a switch port. So if I run now this command for, let's say, the switch port command, like show interface gig 1/0/4 and then switch port, this output you would get now. So it says that switch port is enabled, which means it is a layer 2 port. Now you can also see some other stuff like operational mode of this port. So how this port is operating at this moment. So it is working as an access port. If it says trunk, which means this port is working as a trunk port. So you will always have to look at the operational mode. Operational mode would dictate whether your switch port, whether your layer 2 port is working as a trunk port or as an access port. And I believe that all of you are familiar with the differences between access port and trunk port. Although I will also explain it to you. But I hope that from CCNA you still remember the differences between access port and trunk port. And apart from that, you could also look at the VLAN membership. So by default, it is a member of VLAN 1, access mode VLAN. Look at this. So by default, this switch port is a member of VLAN 1. So this is your switch port. So what we found today is that by default, all the interfaces on your switches are switch ports, are layer 2 ports. Even though if it is a layer 3 switch, like currently I am working on a layer 3 switch, still we found that its all interfaces were switch ports or are switch ports. We converted some of them into layer 3 by using no switch port command. Like we could run this command once again. We could see that how we disable the switch port on the interfaces by running this no switch port command. And apart from that, I would also like to show you that when you convert a port from layer 2 to layer 3, in background, your switch would create some extended VLAN automatically. So if you run this command like show VLAN brief, you would not get that output by running this command. By running this command, you cannot really get to know that which all extended VLANs were created in background when we converted layer 2 ports into layer 3. If you want to get those VLANs which were created for the internal uses by the switch automatically, then the command would be show VLAN internal, show VLAN. What is the command for that? Maybe the switch is not supporting that command here, but that's the command actually that we use here, to look at those VLANs which switch created by its own when we convert a layer 2 port into layer 3 port. So this switch is not supporting that command. But anyways, because it is a virtual switch, so there will be instances where it will not support all of the commands. It can happen. So let me also access one physical switch from my lab. So if I go back and say that, you know what, let me access to my terminal server, and then from there, I will try to access one of the physical switch here. Line 34. So this is real physical switch. I'll show you the version, the OS version, as well as I would run all those commands which I was trying to run on that virtual switch, right? So if you see show version, can you see that which OS version we are using here? 16.12.9, correct? Let me do one thing. Let me access switch 1 then. Maybe this switch is the 9300 series of switch. Show version. So first of all, look at that which version we are using here. So which iOS XE version we are using? 17.12. And if I scroll down a little more, so it says that this switch has been up for 1 day and 20 hours, correct? For about two days. And then a reload reason was power on, which means that we lost the power and then probably power was restored, and that is why the switch was rebooted. And if you get down here again, you could see that we are using DNA Advantage, Network Advantage license. And I told you that if it is a physical switch, then it will give you all the numbers. So now you could see all those numbers which we were unable to see on a virtual switch. Also, you can look at the space of the flash, the physical memory, how many interfaces are there. So you could see that there are 28 gigabit Ethernet interfaces, and there are 3 virtual Ethernet interfaces created on this switch. And then if you get down, you can also see the model. So this is the model that we are using here. And also you could look at the serial number of your system. And then also you could run the same command, show system or show inventory, right? Show inventory. So that would give you that much of details, system serial number, but also the power supply and all that kind of stuff. And apart from that, if you now run the command show VLAN brief, so that would give you a list of the VLANs that are already created on your switch. So you could see that VLAN 1 is there, and then we have got some other VLANs like 3001 and 3002. Apart from that, if you look at show IP interface brief, show IP interface brief. So that would give you a complete idea that how many gigabit Ethernet interfaces it has got. So basically it told us that it has got 28 interfaces, gigabit Ethernet interfaces. Why? Because there are 24 gigabit Ethernet interfaces, and then also it has got these 4 interfaces available. Gigabit Ethernet 1 by 1 by 1, then gigabit Ethernet 1 by 1 by 2, 1 by 1 by 3, 1 by 1 by 4. So those are 4 additional interfaces. So in total you have got like 28 gigabit Ethernet interfaces, and then 3 virtual interfaces were created, and that is a correct statement. One is for like you could see that. And apart from that, it also has got a management port, dedicated management port. Although I have shut it down, I'm not using it, but yes, you have that dedicated management port available on this switch. Now on this switch, I would also run this command, show VLAN internal. They have removed that command syntax completely from ISXE maybe. But anyways, the command syntax was show VLAN internal uses. That is the command. And that would give you an idea that how many internal VLANs it has created in background for its internal uses. But this IOSXE switch is not really supporting this command here. So let me do one thing quickly. I would access the lab, which basically I'm going to use to teach you switching. So basically I have 4 switches in my lab, just 4 switches, but interconnected in full mesh physical connectivity. So I've got full mesh connectivity between the switches. So let me just open it up. I hope everyone can see my switches here. So this is my topology, which I will be using here throughout your training. Throughout switching, I'll be using this topology. So I've got like 4 switches in this topology, and all are interconnected in full mesh with redundant connection. So I've got redundant physical connectivity between all switches. And there is a full mesh connectivity, like all switches are interconnected, Anyways, I'll try to take the access of one of the switch here, and then I can run that command, which I just tried to run on the ISXE. So give it a moment, please. It's just booting up, and very soon it should be up and running. Now we are on this switch, and I would run the same command over here, right? Show VLAN internal usage. Now you can see that command is supported by this switch. Now let me see what we have got for IOSXE. Maybe this command was already depreciated, or maybe if there is another command syntax for IOSXE. Yeah, it has been obsolete. So that is why the switches which are basically running the IOSXE do not support this command syntax, because this has been obsolete. So because on this switch, I'm still using iOS version 15 probably. Let me see that. That is correct. So we are using 15.2. So there we had this command, but it has been depreciated from IOSXE. So it's an obsolete command now. So you don't really have to learn about it, by the way. If you are working only on IOSXE, then you don't really have to learn about it. But anyways, what I wanted to tell you is that if you are working on Cisco iOS, let's assume that you are working on Cisco iOS, because if you are still working on older switches, they do not support IOSXE. So you must be working on Cisco iOS then, not IOSXE. So in Cisco iOS, what happens is that when you convert one of the switch port into layer 3, let's assume like currently all of its interfaces are layer 2 interfaces, all of them. Let's try to convert this gig 1/2 as a layer 3 port. Correct? So I'll move on layer interface gig 1/2. Currently it is a switch port. In fact, we can validate that. Show interface gigabit 1/2 and then switch port. So you would see that switch port is currently enabled for this port. So it is a layer 2 port. But if you convert that port into layer 3, then you have to run this command, no switch port. And then you can allocate direct IP address. So for an example, if you wanted to allocate 101.1 or maybe 10.1 like this. So we have allocated this IP address 10.1 on this interface. And if you say show IP interface brief, it must be displayed there that this IP address is allocated on this interface gigabit Ethernet 1/2. Then after, if you run this command, show VLAN brief. So you still have that default VLAN. But what happens is that in background, when you convert any layer 2 port into layer 3, switch creates extended VLAN automatically and will place that port into that extended VLAN automatically. But in the output of show VLAN brief, you would not get it. You have to run this another command, show VLAN internal uses. That is where you would see that. Now you could see that extended VLAN, because the range of the normal VLAN starts from VLAN 1 and goes until VLAN 1005. And then extended range of VLAN starts from 1006 and goes until 4094. So you could see that your switch has created an extended VLAN automatically and has placed your interface into that extended VLAN dynamically. You don't do anything for that. The only command we executed on that interface gig 1x2 was just no switch port, to disable the switch port, to convert that port from layer 2 into layer 3. This is what we did. We have not done anything fancy. We have not done anything extraordinary. We ran a very simple command there, and that was no switch port command. But in background, it created this kind of extended range of VLAN and placed that interface into that VLAN automatically. Now, what you could do as well, like if I go back and then say gigabit Ethernet 1x2, I could go back and I could make it layer 2 port once again. So interface gig 1x2 and then make it switch port. You would see that this interface will once again become a layer 2 port, and it will remove the IP address automatically. So if I say now show IP interface brief, you would see that the IP address is no longer allocated on that interface. Do you see any IP address allocated on interface gigabit Ethernet 1x2? No. And in fact, if you say show VLAN internal uses, do you see any VLAN out there? I also don't see any VLAN, because there is no layer 3 port available on this switch. So the moment you convert any layer 2 port into layer 3 in background, it creates the extended VLAN. But it creates extended VLAN starting from 1006. That is called ascending order. Of VLAN allocation. I can also change it. Let's say I want to start creating extended VLAN from the last, from 4094. Then 4093, then 4092, in that order. That is called descending order, right? So you can also run this command like VLAN internal allocation policy, and then you have these two options, either ascending or descending. So by default, it was following the ascending order. Now I can change it to descending order like this. And then after, if you go back to gig 1x2 and you say no switch port, so it will create extended VLAN once again. Show VLAN internal uses. See which VLAN it has created this time? The last one, 4094. And if you convert few more interfaces, let's say 1x3, and then no switch port, and then interface gig 1x1, and then no switch port. Make sense?
No need to do like that then.
I mean, obviously, even if you have got multiple interfaces on your router, it is not mandatory to allocate IP address, but that interface won't work until you allocate the IP address. But for now, I have just converted interfaces into layer 3, but I did not allocate the IP addresses, right? Now, if you say show VLAN internal uses, you would see that it has created VLANs in that sequence only. 4094, then 4093, then 4092, and that is called descending order. But with iOS XE, it does not need to create those extended VLAN anymore. And that is why this command has become obsolete for iOS XE. And that is why this command is not supported by 9300 series of switches running with iOS XE. Does that make sense? So when you convert any layer 2 port into layer 3, like traditionally in Cisco iOS, it would go ahead and create the extended VLAN and will put your interface into extended VLAN automatically. But this process is not needed anymore on the new switches in iOS XE. In iOS XE, when you say no switch port, it doesn't create any extended VLAN there. It does not need to. It will simply convert your layer 2 port into layer 3 without creating any additional extended VLAN. So that is why that command was obsolete from ISXC. So that's one difference that you could tell now anyone when it comes to Cisco IOS and Cisco IOS and Cisco IOS XE. But by now you would have observed that mostly commands are, the command syntax is like show version, show VLAN brief, converting your ports, layer 2 ports into layer 3, or maybe from layer 3 back to layer 2. It's all same among iOS and iOS XE. So anyways, I'll go back here and then I'll just say that interface range gigabit 1 by 1 to 1 by 3. I can also pick up the range of the interfaces. And that eliminates, let's say you need to implement a few commands across 10 different interfaces on the same switch. Now you have got two ways. Either you go to each individual interface and run those commands, or you just go to that range of interfaces. So I'm not sure that if you have ever used this range command in past. If not, then you should learn this command as well. This is how we can define a range of interfaces. And then you could say that this is switch port once again. So all of these interfaces now will become switch port, that is layer 2 ports. Make sense? So this is how we could also pick up the range of interfaces. Now coming back to 9K series, 9300 series of switches, like here we have this 9300 switch. It has all interfaces as gigabit Ethernet 1 by, this is how we are representing the interface IDs here. Gigabit Ethernet 1 by 0 by 1, 1 by 0 by 2. Sometimes it will be like 1 by 1 by 1, 1 by 1 by 2, 1 by 1 by 3, 1 by 1 by 4. Sometimes it will be 1 by 2 by 1, 1 by 2 by 2, 1 by 2 by 3, 1 by 2 by 4, 1 by 2 by 5. So that depends, So usually if your switches are standalone switches, this is how your interfaces will be displayed. But if you have configured a stack of switches, you have configured stack. If you enable stacking, let's say stacking is nothing, but it is a concept of converting multiple physical switches into a single virtual switch. So let's say you have got 4 physical switches. You want to convert all those 4 switches into a single virtual switch, logical switch, into a single virtual switch. Because see, if you are managing all 4 switches independently, let's say you needed to create a VLAN, then you have to log into all 4 switches and create that VLAN. You needed to delete the VLAN. Again, you have to log into all 4 switches individually and delete the VLAN. You need to make any configuration, then you will always have to log into all those 4 switches individually and make the configuration changes. And that takes really long time. So, and that is not the only problem, but also, if you are putting up your interfaces into VLAN on switch 1, then you have to log in onto switch 1. If you have to change the VLAN membership on switch 2, then log in on switch 2. If you have to change the VLAN membership on switch 3, then you have to log in on switch 3. Now, so obviously you have got lots of administrative overhead. Now, to reduce that administrative overhead, what you could do is that you could create a stack of switch. You could interconnect your switches using a stack cable. The moment you interconnect your switches using a stack cable, get them rebooted. After reboot, they will start working as a single virtual switch. Now you take the console of one switch. When you say swipe interface brief, it will display the list of all the interfaces across all 4 switches. When you create a VLAN on one switch, it gets created across all 4 switches. When you delete a VLAN, it gets deleted across all 4 switches. And from one switch only, you can provide the VLAN membership for any switch port. So that's the kind of advantage that you get by configuring the stacking. Also, we call it stack wise. So we have got like a stack cable. So we have a topic called stack wise. That is where I will discuss it in more details. And I can even try to access switches which are already configured in stack. And then I can try to display you that, okay, this is how, if we create a VLAN on one switch, but then it gets created across all the switches which are part of the same stack. So it's a kind of virtualization, like clubbing multiple physical switches together into a single virtual switch. Anyways, so these are the interfaces on this switch. So I hope that everybody has understood now the concept of the switch port command. So switch port command will always be used to enable and disable, or I would say, in other words, I would say that to convert your interfaces from layer 2 to layer 3 and vice versa, you would use the switch port command. But remember that by default, all your ports are switch ports, which means layer 2 ports. The meaning of switch port itself is a layer 2 port. If switch port is enabled, which means your port is a layer 2 port. If switch port is disabled, which means your port is a layer 3 port. And remember, layer 3 port is useless unless you allocate the IP address. Like on router, if you do not allocate IP address on its interfaces, can you use your router? No. Similarly, on layer 3 switches, let's say you have converted a port from layer 2 to layer 3, but then you do not allocate the IP address. Then obviously it's useless to convert that port from layer 2 to layer 3. Like even on this switch, I have got multiple interfaces, multiple layer 3 interfaces here. You can also look at here. See, I've got like 4 interfaces, physical ports that were converted from layer 2 to layer 3. And that is why we were able to allocate those IP addresses. Remember, you can allocate IP addresses on your switch, on your switch interfaces only if they are layer 3 interfaces. If they are switch port, then you cannot allocate IP addresses to them. You can create SVI. You can allocate IP address to your VLAN, but you cannot allocate IP address directly on your physical interfaces as long as switch port is enabled. And by default, switch port is enabled. I hope that now all of you have understood the meaning of switch port. Now remember, if your port is a switch port, then it will allow your STP on that port to be running. Maybe VTP updates will go out of that interface, and then that port can be either access port or a trunk port. But if your port is a layer 3 port, then it will never participate in STP. It will never allow DTP, VTP updates, right? It will never be part of any VLAN. It will never be a part of any VLAN. You cannot make it trunk port if you already converted it into layer 3. So if switch port is disabled, then you cannot make it trunk port. Does that make sense?
So is there any global command to turn off all these switch, like not giving on particular?
So that is what I told you. Pick up the range of interfaces and then run the command there. All right. The next thing that I'm going to cover now is SVI, Switch Virtual Interface. All of you must be aware that what is SVI. So remember that when you allocate an IP address to a VLAN, that is called SVI. Like on this switch, you could see that we have allocated this IP address to this VLAN. So like if I show run interface VLAN 3001, we have allocated this IP address to this VLAN. So this is called SVI, Switch Virtual Interface. We can also create them. So for an example, if I go back to this switch 1 here, and then if I say no IP address is there, right? And then after, if I go and create, let's say, show VLAN brief. Do we have any VLAN? Yes, we have got many. And then if you want to create SVI, even for VLAN 1, you can create SVI interface VLAN 1, say no shutdown, and then IP address. Let's say you wanted to allocate IP address as 10.1, correct? 10.1. So now we are allocating an IP address to a VLAN, and that is called SVI. Show IP interface brief. Now you would see that we have allocated an IP address to this VLAN 1. This is called SVI, Switch Virtual Interface. So it's a virtual layer 3 interface. It's a virtual layer 3 because it is not a physical interface. It is a virtual interface. And generally you would create SVI for management access of your layer 2 switches. Because on layer 2 switches, you can create at least one SVI. And generally we create that SVI for management VLAN on layer 2 switches. And on layer 3 switches, not only for management access, you can create SVI, but also for inter-VLAN routing. So to perform inter-VLAN routing, you can also create the SVIs. I hope everybody is comfortable. Hey guys, don't put anything in chat. If you have got anything, if you want to say anything, just mute yourself and speak up. You all are free to participate actively. You don't have to sit quiet. You are not watching video. I'm not playing a video, a comedy show or whatever that you are just, watching. You have to participate a little actively, like keep asking questions, keep asking your concerns. Anyways, so I hope that SVI is all good now, and SVI mainly we will be using it for inter-VLAN routing. We will be using SVI for the purpose of inter-VLAN routing. Now on switches, there are two protocols that we must be aware of. One is called CDP and the other is called LLDP. And even you must have heard about them during CCNA. So if I say, let's say, show CDP neighbor. So CDP is by default enabled across all Cisco devices. So if you particularly talk about Cisco routers and switches, CDP is by default enabled. CDP stands for Cisco Discovery Protocol. And you know what? This protocol really helps us to draw the physical diagram. If you don't know the physical connectivity between the devices, if you don't know the physical connections, and you need to draw the you need to draw the drawing, you need to draw the diagram, then this command and this protocol is really gonna help us. Like you could see here, when I ran this command show CDP neighbors, it will tell me that how many neighbors, how many other devices are connected to me and how they are connected to me. And not only my local interface will be displayed, but also the remote port ID will also be displayed. Like if you look at here, the very first entry, like we can also run the command like this, show CDP neighbors on gig 0 by 0, let's say. So I want to see that which device is connected to me on interface gig 0 by 0. So I hope that you got this idea now that on gig 0 by 0, there is a device that is connected to me, that is switch 2. And this is my local interface. This is my interface, gig 0 by 0. This is my local interface. And this is the capability of my directly connected device, which means it can perform routing, it can perform switching, it also supports IGMP. IGMP stands for Internet Group Management Protocol. Generally, IGMP will be used in case of multicast routing. I'm not covering multicast routing at this point in time, but just to let you know that IGMP would be used for multicast routing. And then this is the remote port ID. So this port is available on where? On switch 2. And this is my local port. So now I can draw the diagram. I can easily draw the diagram, and I can, I got this validation that on switch 1, on its gig 0 by 0 interface, switch 2 is connected using the same interface 0 by 0. You can see that we are using same interface on both switches. So switch 1 and 2 are interconnected using gig 0 by 0. So I draw this diagram here. So that way we can draw the diagram by looking at the show CDP neighbor output. If you do not specify the interfaces, and if you simply say show CDP neighbors, it will display all the directly connected devices and their capabilities as well. So even if I go back to my physical device here, and if I run the same command, show CDP neighbor, look at this. It will tell you that how many devices are connected. Even it will display you the platform. Like in case of virtual devices, it will not display anything there, but if you have got a physical device, then it will display the platform as well. And of course, its capability. Now, CDP is a Cisco proprietary protocol, which means that CDP can be enabled only on Cisco routers and switches. How about if Juniper switch is connected? Can we enable CDP on Juniper devices? Of course, no, we cannot. We cannot enable CDP on Juniper devices. Now, if we cannot, let's say switch 1 is a Cisco switch, switch 2 is a Juniper switch. Now, would I be able to see Juniper switch in the output of show CDP neighbor? No. Why? Because CDP cannot be enabled on the Juniper side. So that is where we needed a open standard protocol, open source protocol, that we could enable on, not only on Cisco, but also on other vendor specific switches, like on Juniper switches, Avaya switches, XP switches, and so and so. So if you say show LLDP neighbor, you would see that LLDP is not by default enabled. LLDP is not by default enabled. And in fact, let me complete CDP first. I've not completed CDP yet. So if we look at show CDP neighbors, this is the information that you get. But also you could try to get the detailed information, like detail. When you put this detailed keyword, it would give you detailed information. So it says that, hey, I've got this device switch for, it has got all these capabilities and connected on this interface gigabit Ethernet 1x1. So this is my local interface, and this port ID, this is, the other side of the interface. And, they are using this iOS version. And then this is the VTP management domain name, and then this is native VLAN, this is duplex. So all this information will be displayed, and even it will give you the management IP if any management IP is configured there. Like for an example, if I go back to that physical switch here, and if I run that command show CDP neighbor detail, it will give you the management IP information as well. So you see that it says that, hey, I have got a device connected called branch 1 switch 2, whose IP address is this. This is platform. This is my local port. This is remote port. This is the iOS version. This is the peer MAC address, VTP management domain name, duplex, the management IP of the other side. So all these information can be gathered, or we can have it as part of the CDP neighbor table command or CDP neighbor table. So we can get all this information. Now CDP packets are sent in every 60 seconds periodically. The CDP hellos are sent in every 60 seconds. And if you say show CDP neighbors, you would see your hold interval is also 180 seconds. So your hold timer might get reduced until 120, and then again it will go back to 180. So it's like 135 now, and then 131, 129, 126, and then again reached back to 180. Because in every 60 seconds, we are receiving the CDP hellos. So the hold interval is 180 seconds and hello interval is 60 seconds. You want to change that, you can change it. So CDP timers, CDP timers and then hello interval. So by default, it is 60 seconds, but then you can also make it like maybe 30 seconds. So now CDP will start sending packets. Like this switch will start sending CDP packets in every 30 seconds. Then CDP hold time is by default of 180 seconds. But then you can also change it to like 90 seconds, like this. So this is how you could change your CDP timers. But it is never recommended to change the CDP time intervals. We don't change it in production environment. But yes, you should be knowing that how do we change it if needed. So let me remove that. Not only that, but also you can enable and disable CDP. For an example, you want to disable CDP globally. Then in global configuration mode, the command would be no CDP run. Now, if I want to look at show CDP neighbor command, it would say CDP is not enabled. You want to enable CDP globally, then CDP run command would be applicable. Now, if you say show CDP neighbors, this is the output that you would get. It would start learning the neighbor switches once again. But it has to wait until it receives the CDP hello from other switches. Anyways, you could also enable and disable CDP on per interface basis. Example, if I go to interface, let's say gig 0x0, and I want to disable CDP on this interface only, then say CDP, no CDP enable. So that CDP gets disabled on this interface only. You want to enable it back, then CDP enable command syntax would take place. So you have got both ways to enable and disable CDP. Either you can enable, disable CDP globally or on per interface basis. But as I told you before, that CDP is a Cisco proprietary protocol. That is why, LLDP is more preferred, because in most cases, you would see mixed environment, not just using only Cisco devices. So if you are using only Cisco devices, then that's a separate story. Then you can simply rely on CDP. But then you should also know that how to enable LLDP. To enable LLDP, it's very simple. Say LLDP run, same as before. And then you should go to each switch. Like I can also take the console access of switch 2. So you move on switch 2 and then say LLDP run. Then move on switch 3. So we will have to get it enabled across all 4 switches in my topology. LLDP run. Then move on switch 4. And once again, the function of CDP and LLDP is same. You know, the work done by CDP and the work done by LLDP is all same. Now, if you say show LLDP neighbors, look at this. So we have enabled like LLDP across all other platforms, all other switches. And that is why I was able to get them in the LLDP neighbor table. You can also look at the detail over here as well, similar to CDP. But LLDP gives you more information as compared to CDP. You know what? Sometimes you would see that IP phones and IP cameras are connected to your switch. Then your switch needs to identify that how much power I need to supply. Do I need to supply 20 watts? Do I need to supply 15 watts or 5 watt or 25 watt or 30 watt? So that information is also gathered by switches either using CDP or LLDP. That information is also gathered by switches by using either CDP or LLDP. If you are using Cisco camera, Cisco IP phone, then CDP can work. But what if you are using Cisco switch and then Avaya phone? Then CDP will not work. Then you will have to enable LLDP. And then you could also go to interface mode. And you could say no LLDP transmit, which means it will stop transmitting LLDP packets out of this interface. You could also say no LLDP receive, which means you would stop receiving the LLDP packets from this interface. So that is additional advantage of LLDP over CDP. In CDP, either you enable or disable the CDP completely on your interface. But in LLDP, you can also say that, hey, I want to receive the LLDP packets, which means I want to see my neighbor, but I don't want my neighbor to see me. So I will not send. So you could simply say no LLDP transmit and then just say LLDP receive. I can see my neighbor now. Like if I say show LLDP neighbor, I would see my neighbors, but my neighbors will not be able to see me. So that is another advantage of LLDP over CDP. I hope that everybody is now comfortable. And then LLDP timers, you know, you can change the hello interval and also you can change LLDP hold time. So you can also change the hold time. It's up to you. But by default, show LLDP neighbors. So hold time is 120 seconds. LLDP, and then it should have, so LLDP hello interval is, and then hold time advertised is 120 seconds. Make sense? And show CDP, as I told you, hello interval is by default and hold time is 180. And we can always go back and modify those timers. So I've also covered now CDP and LLDP both completely. But remember, it doesn't do anything else other than what I explained to you. Like it simply helps you, both of these protocols will help you to identify your physical connections, physical topology. Now, when it comes to campus area design, campus network design, you know, I have already spoken about it even yesterday. Either you follow 3-tier architecture or you follow 2-tier architecture. Nowadays, we are following in most cases 2-tier architecture. Not in data centers, but especially in local area networks, we are following the 2-tier architecture. In data centers, we are still following kind of 3-tier architecture. So in 3-tier architectures, you have got access layer, distribution, and core layer. Whereas in 2-tier architecture, you have got access layer and then the combination of core and distribution. So either you call it distribution or you call it core, it's up to you. So access layer, you know that your endpoints will be connected to the access layer directly, like your laptops, your desktops, your printers, IP phones, your cameras, IoT related stuff, whatever. So all your endpoints will be directly connected to your access points. Distribution, like generally all your access switches will be connected to distribution switch. Like for an example, you have got a campus consisting 5 buildings. In each building, you have got multiple floors. In each building, you have got a distribution switch. From that distribution switch, connections goes to each floor where you have got your access switches. Now, from that distribution switch from each building, you have got a data center, small data center somewhere in one building. That's where you have got core switches. So the connections from distribution will come to your core switches. That's how three-tier architecture works, just like this. So in a single building, you have got distribution and access. So each building block would have distribution and access. And then from each building, connections will come from distribution to your core. Core will be located somewhere in one building where you would have your kind of data center. So if access switches needs to speak with another switch block, then they just have to go through the core switches or maybe via distribution switches. This is called multi-node core. Then two-tier hierarchical model, and also it is known as collapsed core, where you have got this type of architecture. You have got core layer and then access layer. So all your access switches are directly connected with core layer switches. Now, type of traffic flow. So usually you would have local traffic, remote traffic, enterprise traffic. Local traffic is like maybe within the same VLAN, Remote traffic going from one VLAN to another VLAN. Enterprise traffic is going from one location to another location, kind of thing. And you can try to understand it from here only. So within same building, same VLAN, going from one access to another access via distribution, fine. From within the same VLAN, then you have got local. Then from one VLAN to another VLAN, you have got remote. And then enterprise, like going from one location to another location. That is it. So next topic is going to be switch operations then. But before that, try to focus more on these designs, two-tier architecture and three-tier architecture, and try to be, to become more comfortable with these terminologies. And if you have got any doubts, do let me know. You can ask me questions tomorrow, and then we can discuss about these terminologies. But these are just terminologies. There is nothing like technology. So the next thing that we have got here is the switch operations, which is really important for us to understand the functions of a switch. Like you must have heard about address learning, filter and forwarding, decision, and loop avoidance, even in CCNA. That's what we're going to revise here in CCNP. And then after we'll talk about some other stuff. I hope that now you are becoming more familiar with the switches. You are becoming more comfortable with the switches. So we'll cover the switch operations. And even before I cover the switch operations, I would like to create VLANs, putting interfaces into VLAN, or maybe we can cover that later. It's up to you when you want to really cover all those topics. So first we can cover the switch operations, and then after we can talk about the VLAN and trunks. And then we can talk about dynamic trunking protocol, then inter-VLAN routing, then spanning tree, and all that kind of stuff. Okay? So that we will cover tomorrow. If anybody has got any questions from online participants, go ahead and ask those. If not, then I'll stop screen share and we'll continue tomorrow then.